So student, after seeing the very simple concept, as you can say A star algorithm, and what is the meaning of the A star algorithm. So over this slide or diagram, you can see we have taken a very simple example of the A star algorithm. And what is the meaning of the A star algorithm? What is the sense of the A star algorithm? We have seen. So how we can find the best part, as we have seen again today, how we can see. After this point, we have very important theoretical point, and from this theoretical point, we will see as a numerical to understand this concept properly. So in the exam time, a question can ask by myself or by ask at the time in the interview. Can anyone ask the question? What is the problem graph in the AI? So many AI problems can be cast as the problem of the finding the path in a graph, and we have seen problem graph by the various searching techniques as well. If you remember the searching techniques, what are those searching techniques? So I can write over here. Just you can note down in your mind as well. We have seen the problem graph by the various searching techniques. I can write over here. We have seen by the searching technique or search strategy. Search strategy. And what are those? If you remember the DFS, BFS, and Unicost, uniform cost search, and then we have also used the A star. Okay, so these are the various mechanisms by which we have already seen. So a graph is made of the nodes and arc. That is the point. So if you're talking about the problem graph, so a graph is made of the nodes and arc. And arcs are the order pair of the nodes that can have associated cost. Yes, of course, in the A star algorithm we have also seen, and in the UCS searching techniques we have also seen the cost. Suppose we have a set of the nodes that we call the start node, and set of the nodes that we can call the goal node. So these start nodes and goal nodes we have already seen. Okay. So many things we have already seen, but here we are looking for the everything in a scratch. We are just revised proper, you can say. So solution is a path from the start node to the goal node, and we have already achieved this concept by the DFS, BFS. But if you're talking about the cost, then this UCS is more important. DFS and BFS, the cost was not mentioned clearly. And if talking about the food, so in the AI, many people will love to work with the A star algorithm. And why A star algorithm and A star algorithm is more useful in the problem graph? It is very simple. A star means we are choosing the one path only. We are not moving to the other path. If you're looking at this point right now, look at this example. What you have been observed? We have a two option. Either we can move to the A to B, or you can move to the A to C. Why are not choosing A to C? Because its cost very high. So we are choosing the A to B. So out of these two options, you are choosing only the one option. That is the point. So here A star means we're talking about the AND star. The A meaning stands for the AND. Okay, that is the point. But when talking about the A star, we will talk about the A star algorithm. That is our today's topic. So A star means and or graph. So in examination or at the time of the interview, someone can ask you what is mean by the A star algorithm. So you should not be confused. So A star algorithm sometimes is also known as, this is a, let me clear to term, and star algorithm. That is the point. Okay. So in the exam time or the at the time of interview, someone asks you the what do you mean by the and star. So that is time means we are talking about the A star search algorithm. Now, so this graph we have to see by the problem to solve our problem. So we have a problem graph. Here we have the we have already seen the A star, but it's time to see the another searching mechanism, that is the A star search algorithm. So what we have seen, just let me explain the some theoretical point over here one by one. The depth first search and the BFS, that is the breadth first search given earlier for the OR tree. Okay, if you remember the example, or the graphs can easily adapted by the AND or graph. And the domain difference lies in the way termination conditions are determined, since all goals following an end nodes must be realized. So where a single goal node is following an OR node, so will do. That is the point. So for this purpose, we are using the AO star algorithm. So that is very important points in the depth first search and VFS. We have seen we are using the OR graph because we can have the multiple goals. So we can move from the our finding the goal by choosing the shortest path or determined by the cost. But when we have the mix of the two things, one is the AND algorithm and or, so we can have the multiple goals. So how we can choose? So this is very problem we can have. So to avoid the such problem, it is better idea to we can shift or we can move to the A star algorithm. So just let me explain again my previous example as we have seen today. E, and we have another path that is A to C and A to E. Why we are not moving this path? That is the point. Because we have only right to choose only the one path, we have option. We have this option we have opted. But look at the other side. Maybe there is no guarantee, but maybe we can also have the minimum cost. Here it is not clarifying, but suppose that I'm taking just doing some amendment over here for betterment. Look at this point. Uh, Suppose I'm just replacing something here, h just equal to 1 I'm putting. Okay, I'm keeping this cost as it is, and I'm just replacing some value as it just here, and I'm just changing something for understanding purpose. H equal to just 1 only. As initially you have not shifted to A to B, A to C. So if I'm choosing A to B and A to E, so what would be the my cost? 2 plus 3 plus 1 plus 2. Am I right or not? Tell me right now, yes or no. So 2, 3, 2. So that would be the uh, 8. If I'm choosing this path A to B and E, so this would be the 8. Am I right?
Yes, sir.
Tell me. Okay. If I'm just thinking about the other path that I can explore, A to C and then E. Let me write correctly. This one. A to C and then E. So what would be my cost? 2 plus 1 plus 1 plus 1. So now what you are getting? What you are getting?
5.
5. 5. Okay, let me just do some amendment for a betterment. Instead of the 1, I'm just can choose the 3 or I can choose 4. Then I will explain more better. What is the think we can just 4. So A to A, I'm A to C, I'm not moving because it is just having the high cost 6. Okay. Uh, A to B, that would be represented by the 2 plus 3, that is the 5. But A to C, I'm just having the 2 plus 4, that is 6. So this is the reason I'm choosing the A to B. But if I'm looking at the other path, this one, so 2 plus 4 plus 1 plus 1. So in this case, you can say 6 plus 2, 8 is again coming. Okay. So that is the way, or maybe maybe the here heuristic function may cause a zero. So suppose I'm just getting the zero over here. So this can lead to 7. So this could be the another path. But as the initial level we are taking the CN, I can move to A to C. Why? Because I'm thinking about the this function, this path just lead to the high cost. But look at the other side. Maybe if I'm going too deeply, I'm going to the this path in deeply. So maybe I can get the least cost. But I'm not thinking. I'm just thinking about the present and the current node or current path what we have. So this could be the reason, and that can be identified by the AO star algorithm. Now the problem is clear. This problem is clear. What we are looking into the AO star algorithm, then I will explain with the help of the example. Or should I
Yes.
explain once again?
Excuse me, sir.
Yes, tell
Sir,
me.
once again you explain, sir.
Uh,
Sir, if we move from A to B, so we have to add 5 plus 2 or we have to do 2 plus 3. Can you please
2 plus
explain?
3, 2 plus 3. See, this is the reason, this is the point you have to get it once again. Uh, you are moving from A to B. So the cost function of A to B will be counted as 2, and the what is the heuristic function at which we are reaching on such node, that is the heuristic function value will be counted. So 2 plus 3 will be not 5 plus 2. Okay, now clear?
Okay. Yes, sir. Clear, sir.
Yes, sir.
So this is the point. Okay, so who asked this problem? I should I explain once again?
Sir, me, sir.
Okay, so I was thinking about this point. Let me just do one thing for a better way. Okay, just this point here. This one. See, I'm first taking to you. You are moving A to B first. That cost was that cost was 5, and A to B, not A to B, E to C. That cost was 6. So you will choose A to B. Am I right?
Yes, sir.
Okay. So what I did, I just do some amendment. Then B to E I can go. So next I can go A to B, and then I can go B to E. So I will talk about this point. So what would we do? That would be the 1 plus 2. So already we have the 5, and then we have 1 plus 2. So that would be the 8. Okay. Is it clear right now? I'm not talking about the path cost. I'm talking about the total function cost. Now it is clear.
Yes, sir. Yes, sir.
But as an initial level, this was my point. At initial level, we have not moved on A to C due to higher cost by B. Okay, so this is the reason. But I was talking about the look at other side. This is my point. Suppose I'm moving A to C, no problem. The cost will be 2 plus 4. 2 plus 4. That would be 6. Is it okay right now?
Yes, sir.
Okay. And here, this function cost where which I'm choosing path A to B in E, so the cost will be 8. I can write A to C, and then I'm just going A to E, sorry, C to E. So here I'm getting the 2 plus 4, that is 2 plus 4 plus 1 plus 0. So suppose I'm writing here 1 plus 0. I'm not writing 1. Okay, I'm just taking the heuristic function as a leaf node can have the 0. It is also possible. Okay, so I'm taking as it is. So here what I'm getting. I'm getting the 7. So this is the function cost of there's a function cost of this part. So if we talk about the A to B and then E, I'm having the function cost 8. And if we're talking about the A to C and then E, I'm having the function cost that is the 7. Okay, now look at the path cost. This is the function cost. Okay, this is the function cost. I can write over here. Now path cost. So what is the path I have to taken? 2 plus 1. 2 plus 1. And next other one was the 2 plus 1. 2 plus 1. When I'm taking the this one. And when I'm taking this one, so both are having the same path cost. This only random example I have taken here, so I'm getting the same path cost. But what you're observing, if you're talking about the A to C and E, so its function cost is smaller than the our chosen path, that is the A B E. That was the best path we have thought. So here we have to use the AO star algorithm to see the other perspective. That was my point. So what I have written uh, in the depth first search and breadth first search, you can see the OR graph. Okay. But if talking about we are using the A star algorithm. So what we are doing in the A star algorithm, we are using the ORing. ORing means we are looking for the OR node. So what is the meaning of the A star algorithm? A star meaning A star algorithm you will use plus you will use the OR node. You need to look for the OR node for other exploration. Is it possible we can have the other path or not? That is the reason we have the A star algorithm. That is the reason. So now this problem is clear. This is telling to us why A star is needed. Now this problem is clear right now. Why we have to look for the other side of the our graph, that is the AF star. Now it is clear right now.
Yes, sir.
Yeah, that is the reason. So from the function cost we can see the function cost of the A to C is lesser than the A to B which is chosen by us. So why we have not to use? From this perspective, we had to use the AF star algorithm to look at the other side of the other graph or other path as well. This is the reason. So now here, so extra algorithm basically based on the problem decomposition. This is a very important point you have to keep in mind while learning the EOSTAR algorithm. So problem decomposition, for the problem decomposition we have to use the EOSTAR algorithm. So when a problem can be divided into the set of the subproblem where each subproblem can be solved separately and combination of these will be a solution. End of graph or end of trees, we can say please keep in mind it is also known as the end of tree or end of graph. So in the exam time, do not have any confusion. I can ask the question based on the end of tree. So this is also similar to the end of graph. Okay, represent this solution. Decomposition of the problem or the problem reduction generated by the and R. Okay, so we will see this one. Let me explain this end of graph with the help of the very simple example. It's a very simple example I'm taking from your real life scenario. So how to pass an examination? You have two options. Either you can cheat in the exam time, and or you can do the hard work plus pass the examination. So you have the two options. What are the two options? One is a very simple option. You can cheat yourself to pass the examination. So this would be the one solution. This would be the one solution. And what is the other solution with the combination of these two? So this would be the second solution. If I'm using these two options, if I'm using these two paths simultaneously or parallelly, we can say. So here, what I'm using the arc. It means I'm using the X. So in this graph, we are given the two choices. First, we can do the cheating, that is the red line, and work hard. The arc is passed. So when we have more than one choice and we have to pick one, so they apply the OR condition. Okay, we have to pick the one option. Please keep in mind when we have the more than one choice and we have to pick the one choice, so we have to use the OR condition. But that we have already did. But basically, arc here denote the AND condition. Okay. So here we have to replicate the arc between the work hard and pass because by doing the hard work, possibly to pass examination is more than cheating. And this is a very important for your real life scenario as well. We have to replicate the arc between the hard work and pass because by doing the hard work, possibility of passing the an examination is more than cheating. So you have the two solutions. So in the real life scenario, we have the real two solution. I should go this way or I should go this path. So if I'm choosing this path, so what would be the possible outcomes I can have? If I'm choosing this path, so what would be the possible outcomes? So if I'm looking over the cheating path, so definitely my learning will not be fruitful. My learning will be fruitful when I'm doing the hard work and trying to pass the examination. That will be the various options. So red and or all graph we can understand by this way. We can have the multiple options like this example as we have seen this one. See here if I'm looking at the other side, so I have also other option. I can choose other path. Yes, that is also possible. But why you are choosing the other path? Because you have to look at the other side is possible or not. That is the reason. So here I need to explain the EOSTAR algorithm. This is the reason. So before jumping to the EOSTAR algorithm, I have taken the idea here by the help of the simple example. I just have drawn the example over here manual. Just random example I have taken. So this is idea about the EOSTAR algorithm. Now, but before jumping to the EO and EOSTAR algorithm deeply, let me just explore idea about how these two algorithms are different from each other. At the time of the interview, at the time of the vibe, anyone asks you the question, oh, you are familiar with the A star and A star. So what are the differences between these two algorithms? It's very simple. So I have the two different reasons we have. The main difference between the A star and AO star algorithm is that A star algorithm is OR graph and OR graph algorithm, and you have to choose one path. Either you can choose A to B E and A to C B. You can't choose both one. That is the reason. But in the star algorithm, we have the right to choose the AND or OR graph. That is it. So in OR graph algorithm, you just find only one solution. Either OR solution means this or this could be a reason. And but in the end or graph algorithm, find the more than the one solution. That is the reason. Please keep in mind. This is the star I'm putting here, but end or graph, we can have the more than one solution by ending two or more branches. Now, theoretically, the point is clear right now. This
Yes,
theoretical
sir.
point. Okay, one important point you can again. I'm writing here the star over here. Just A star algorithm always gives an optimum solution based on the shortest path with the low cost. But it is not guaranteed that I'm using the A star algorithm always provide the optimal solution. So if you remember the star algorithm in the other example, we have chosen the A, B, E, Y because it supports the shortest path. But after applying the A over star algorithm on the same example, what I will observe, I have the another chance I can have, but there's no guarantee every time I can get the best score. So reason, because A star does not explore all the solution path once the solution is got it. But this is the not drawback. This is the possible thing we can say. What mean to say that once we got the solution, so you will not do the more work on the getting the solution. But as a responsibility of AO algorithm, we will look at the other side of the our solution. If we are looking at the other side, so there may be some chance we can have the shortest path based on the cost. So it is also possible. In this case, we have to understand this point. We have the solution, we have the problem. So we will discuss on that part here. Now, the basic difference between the A star and AO star is clear right now, or any need you need to ask, so you can ask me right now. Difference between the A star and AO star algorithm are clear.
Yes, sir.
Yes, sir.
Okay. Okay. So let me just how a star works. So this is the point we have to keep in mind properly. I hope the image is visible to all. So let me explain what this image is telling to us. The A star algorithm always moves toward the lower cost value. The first point we have to keep in mind. Basically, we will calculate the cost function here, fn or fx is equal to gx plus hx. Okay, and h would be the our heuristic or estimated value of the node, and g would be the actual cost or age value that is here by the unit we can say. So you can see this diagram where it contained by the various information by the different color 1, 6, 3, 12, 2, 1, 2, 10, 10, 4, 1, 1, and so on. So all the details given over here. Are you observing something over here? Are you getting something over here? All the values are written into the different color. Am I right? Into different color. Is it
Yes,
visible
sir.
to all? Okay. So let me explain what is the meaning of these colors values. The purple values are the ages values. The purple values are the ages value, and this is also known as the cost of the such part. And here talking about the red color. So red value is representing the heuristics value of the node. Okay, so B, C, D just contain the heuristic value 6, 12, and 10. And G, H, and J, and E, F, and I also having the own different values of the heuristic. So 5, 7, 1, 4, 4, and 1 is also represented. So what is the other values? What is the other values? The other values is represented by the green color. So that is represented by the new heuristics value for the node we can have. Okay, we can have the new heuristics value. So if talk about this point, so what you are getting, so how we can solve the problem? Can anyone just tell me right now what you're observing from this graph? Yes, tell me right now what you are observing and what is mean by the new heuristics value of the node. Tell me. Yes, tell me. Just I need the answer from the students. What is mean by the new heuristics value? A, B, C, D. Just let me draw the diagram here to explain. A, B, C, and then D. Then G, H, D, H, J. Okay, this is connected by the G. This is connected by the H. This is only connected by the I, and this is connected by the E and F. Okay, this is connected by the E, and this is connected by the F. Next we have the I. We have, yes, at the last we have the I. So I'm just putting all the things information over here. And this is not a I. This is J. Actually, let me write correctly. This is the J. This is J. This would be J. And let me choose first purple color to determine the path. So 1, 1, 1, 1, all are represented by the 1, 1. So I'm just writing 1, 1, 1, 1, 1. This is our cost we have. If talk about the 6, 12, 10, this would be our heuristic value. So here this would be 6, 12, and 10. What are the others? 5, 7, 1, 4, 4. 5, 7, 1, 4, 4. Yes, 1, 4. 1, 4, and 4. And at the last, I will just having the 1. Okay. From this point, before moving to the green point or green part, let me explain all the things information over here. Now, if you talk about the procedure, how the historical will work, so let me explain this thing by the example. First, let me write now the diagram is clear. Yes, on the diagram you need to ask any questions. Of course, you can ask the question on the diagram, then we will explain this thing. Yes, tell me right now. Any problem in this point? The example is clear.
Yes, sir.
Okay, so I need to the answer from your side, the all the people. A to D and A to B C, I can choose this path. So the calculate the cost of the path A to D and A to A B C. What will be the cost? Can you tell me right now?
The A to D would be 1 plus 10, that is 11. And A to BC would be 6, 12, 1, and 1, that would be 20.
Okay, just let me write here to understand this problem. That is very necessary. So you are on the right track. So A to D, we have two options. I can choose this path A to D. So what would be the my cost of the function? And that would be the 1 plus 10, that would be the 11. I'm writing everything according to you. So as we have discussed, A to BC. I'm talking about the first A to B and C. So here what I'm doing, I'm just choosing these two one. I'm choosing these two. So what I'm applying, I'm applying the arc. And what is the meaning of the arc? I told you. Just look at the its basic terminology. Here we have the node and arcs, two terms. Okay, so arc I'm using means I'm using the or. Okay, so I'm using the and. I'm using the both. I'm using the both paths or both node for solving the my problem. So that way I'm using the arc. So arc means I'm using the and graph. Okay, so let me explain. So if I'm talking about A, B, C, so first A to B and C. So what I have to do? A to B. So that would be the A to BC. I can write like this one. So the function calls of this would be, first let me move to the A to B. That would be 1 plus 6 and plus 1 plus 12. That would be the 20. Am I right?
Yes, sir.
So what this arc is telling to us? The arc means you're talking about the end. Okay, so you're choosing the both path. So one path you have this one, and other path you have the this two. Now, this is the first point we have seen. So as we have seen, the A to D is less than the A to BC. Then algorithm choose which path, A to D. Yes, tell me.
Yes, sir.
Yeah.
A to D path, sir.
So I'm marking the right over here. So we are choosing this path. So let me just highlight this statement. I'm moving to the A to D. Okay, so this is the path I have been covered. This is a brilliant point. Okay, so now A to D and FE I can go. So we have a one choice, that A to E. Okay, so A to E we can go. So A to D and FE. So that would be the our values. Let me choose right now this one. So we have, if I'm choosing A to D and then E. So what would be the my values? Uh, 11 plus 1 plus 4, and if I'm choosing the A to D and F, that would be the 11 plus 1 plus 4. So this would be the 16, and this would
16.
be the 16, 16. Okay, this is the point. A to D and F E. So we have one choice, that is the F to E. So we can go, that would be the this value. Okay. So here what I have, I can choose the both one or not. Telling right now, I can choose both one.
Yes,
Yes,
sir.
sir.
Yeah. So we have an option. We can also choose both path. So from D to E, and if I'm applying the arc, so just look at our example. If it is just marking the arc over here, just look at this example. In our example, it is also marking by the arc. So with this point, what we have, we are just putting the this mark over here. So it means we are choosing both value. So we can say this would be the A to D and E F. So here, what would be the value? What would be the value here from this point?
Sir,
What?
11 plus 1 plus
11
1
plus
plus
1 plus
4 plus 1.
So 11 plus 1 plus.
1 plus
1
4
plus.
plus 4.
Okay, so I can write like this one. Okay, got it. So this would be your, this would be your total.
21.
Uh, well,
21.
yeah, 20. I'm getting. Okay, correctly. I'm getting. So the my point is over here. Basically, you can observe over here. Basically, from F to E. Okay, from D. From D, if I'm moving from F to E, so what would be the my cost? This is my point. If from D, that is my point. From D, if I'm moving from F to E, so at a time, what would be the cost? This is my point. So what would be the cost? You are moving from A to D via A to D and EF. Then you are getting the cost 21. But from D, F to E, you are moving. So what would the cost?
16, sir.
Okay, so how you can sustain?
Sir, cause we have taken both the path from A to D, E and A to D and F separately. and that is less than arc path. So
See, A to D is clear and A to BC is clear, so we are choosing A to D. So that's why I'm already highlighted that point, no issue. But from D to E and D to F we have. So if I'm talking about the D to E and D to F, so from D, please keep in mind from D, F to E, if you're moving, so what would be the cost? That is the my point. Or F to E or E to F.
So, so 10,
Okay, 10, tell me right now how you're getting 10.
because we only consider the A to D part.
Hmm. See, so how you're getting the 10? Tell me right now. We are considering only the
sir, for F2E we are doing a backtracking now.
hmm.
So sir, it might be possible that 1 plus 10 plus 1 plus 4.
So total would be.
10 plus. Sir, 19. Sorry sir, 20.
So how? See again, you just need. Okay. See, basically the cost of reaching F to E from D, I need the value this value from F to E. I just need this value. Just I need this value. I need. Okay, I'm just drawing a different color diagram, so I need this value first. What is my point? This one. So if you need to from F to E, suppose you need to from F to E this way. So what would be the cost? This was my question. And think and tell me. Everything is written here. The cost from F to D, from the D, I need this cost first. Tell me. I need the correct answer. Everything is in front of you. Think and tell me the answer. It would be 11, it would be 10, it would be 20, it would be 19. I got the various answer, but I need the correct answer. So think and tell me because you have already seen
Sir,
the
it is
answer.
16.
Okay, 16. So how you're 16, how you're getting 10, and how you're getting 10, how you're 11, so how you're getting the 11.
Sir, you have to backtrack to D and then go to E. So it will be 1 plus 10, then plus 1 plus 4.
Okay. Can we have the 10 right now? If I'm speaking about the 10, just can we have the cost means I'm just talking about the function cost. So fx can we have this cost? Can we have this cost 10? Yes. Anyone who is agree with me? So 10 we can get it.
Yes, sir.
Okay. Why? My question is written here clearly. From D you are
So
moving
through
from.
arc.
Okay. See, what was my point? My point to from D F to E, what would be the function cost? Okay. So I'm writing the 10. If I'm writing 10, then how we can get the 10? That is the my. That is a simple question I'm asking. Okay, what you're doing, you are moving from first F to D and then D to E. Okay, is it clear right now? Yes, tell me. Okay, so what is intermediate node over here? D. Okay, and this heuristic values we have already consumed. This heuristic value of the D we have already taken. Okay, so 10. So what we do, we will choose a path that is uh, the heuristic value of the f. From f we are moving, so its heuristic value of the f plus the path cost from f to d, that could be the 1, plus heuristic the path, another path from d to e we have 1, and plus heuristic value of the e will be considered. So here we can get the 4 plus 1 plus 1 plus 4, so that would be the 10. This is the reason, because we are moving that part, so d will not be, we will not use d. So basically what we are getting, the cost of reaching from f to e from d, that is the point, from d would be the 10. And the heuristic value of the d also denote the cost of reaching fe from d. So the new heuristic value of d, we can say that would be 10 rather than the 11. So we can update. That is the reason. This is known as the determining. This is known as the updating the heuristic values. So the cost from A to D remains same as 11. So we are keeping as it is. Suppose we have set this path, we have got the goal stick. Then we will never explore the other path. And this is the used algorithm say. But here we are going to explore the other path as well to see the what happens. So from the our minimum path we have taken, and we're trying to update something the our heuristics value. So in the EO star algorithm, what we are choosing the other path. We're trying to explore the other path by help of the arc, by help of the non-arc. So by help of the arc we are choosing, so we are putting the and. So we are determining the path. But there is maybe some chance we can get the updated values of the our heuristic value. It is also possible or not. So that is the point. So what was the written over here? As I told you, green color means we are talking about the new heuristics value of the our node. That is my point. So in the graph, as I told you, green color means in the heuristics values, and these values we are getting by updating this part. So here you are using the AND. So here you are using the AND. So you will use 4 plus 1 plus 4 as a combination. So D will not be considered as a D. This D heuristic value will not be considered. That is my point. So this will be as it is 10. So nothing will be changed. So no new heuristic value will not be changed, or the new heuristic value will not be applicable over here, because D is already having by the 10. If you're getting the new heuristic value by the our path 4 plus 1 plus 4, so we can say that would be the 9. We are getting the 9. So this would be replaced, so this would be updated. But here we are getting the same. But here you can see that 2 is the our just let me write over here for a better man. A to B I'm using the new, its old heuristic value was a 12. So if I'm moving here, so C to J we have. If I'm applying the backtracking, so the 1 plus 1, so new heuristic value will be the 2 to reach C to J or J to C. This is the only reason. This value we can be updated. This value we can update also as well. So by choosing the updated heuristics value, we can update the heuristic value of the older one. So this is a 2. So how we are getting the 2 1 plus 1. So this would be the new heuristic value, and this will be replaced. Okay, it's 2. And after applying 2 plus 1, so this will be the 3 will be, and 6 will be replaced, and 12 will be replaced. 10 if I'm replacing, there will be no sense because we are getting the same thing. So if I'm moving A to D, so I'm getting the 11. So there will be no changes over here. But if I'm moving A to C, after updating the heuristics value 12 to 2, so my total cost will be 3 rather than the 13. Okay, A to B when moving, so my cost would be the 6 1 plus 3. That is the updated cost. And if I'm choosing the previous one as 1 plus 6, that will be 7. So this is the reason I'm trying to update here new heuristics value. So this green color is showing over here. This green color value is showing over. This is the updated new heuristics value. So here we have seen all this one. So what will the cost of the f over here? We have seen over here. So no need to change over here. But let me continue this point right now. If I'm talking about the other part, first let me write down. This path is clear. This point is clear. E to D.
Yes, sir.
Okay. Let me take the different color to write everything here. Yes. This is a better color. Let me take the another part. Now I'm just thinking about the explore the other path. Explore the other paths. And what are the other paths? A to B and C. If you remember, just note down this value. Okay. So what was the its function cost? You have just observed over here. That is 20. So can we update the new heuristic value? Just see. If I'm moving A to B, first let me explain the A to B. Okay, so A to B, I'm just moving, so I'm spending 1 plus 6, that would be 7. Then I'm just moving A to B and then G, so I'm spending 1 plus 6 plus 1 plus 5. 1 plus 6 plus 1 plus 5, so I'm spending total 11 plus 2, 13. And then A to B and then G and then I. So that would be the 13 plus 1 plus 1. So that would be the 15. So if I'm observing this is the 5 is the our old HG value. So what would be the new value? So we can say from A to G. A to G we are getting 13. Okay. So total 13 function cost we are getting, and from A to G we are getting. So can we replace this point? So total cost will be the here we are getting the, just let me write, yeah, this one. So G2H, what is the total path from G2H? Just move to the, yeah, G2H, sorry, G2I.
1
We have
plus 6 plus 1.
1.
Sir, G2I or G2H, sir?
No, no, G2I. I'm not speaking of G2I. G2I, we have only 1 plus 1, that is only 2. Okay. G2I, we have 1. And from G, if from
It's
G2I,
1 plus
see,
1.
yeah, G2I, if I'm looking for, just please keep in mind,
Sir,
G2I,
16.
G2I, I'm looking at this one. So, no, I'm just coming to a point. G2I, we have only 2. So, if I'm applying this process, the backtracking as a student told me, backtracking, so, yeah, this one. So can be replaced is total cost from the its next path, that is a 1 plus heuristic value of the I, that is a 2. We can replace these two by the 5. Yes, it is also possible we can replace. So this would be our new heuristic value of the G, because G2I you are covering by the only 2. So that is the reason. And we can also same apply here to update the backtracking. We can also apply this one. So we can apply this one would be 6. So here 2 plus 1. So this would be replaced by the 3. That is a reason. We can replace base. We can replace the all the thing. And after updating the all the values, so if I'm trying to get the new path, let me manually update it. So this would be 2. Yes. Yeah. This would be 2, and this would be 10. Am I updating this one? No need to update the 7. 7 would be as it is over here, and 1 will be as it is, and 4 will be as it is. And here, deep nodes are not required to update anything. So if I'm choosing the path A to BC after updating the heuristics value, so this would be 1 plus 3 plus 2, so that would be the 6. But previously it was giving me 1 plus 6 plus 12, so A to BC, it was giving the 20. So 6 is lesser than the 20. So that is the reason Heuristics values can be updated based on the path and what is the last or leaf nodes, or we can say the yes, leaf nodes are containing the heuristic value. So we can update the leaf nodes heuristic value by this one. So we have to check everything, and this can be done by the our and or graphs. In the and or graph, we can update this value. So I can speak over here just what we have done so far. In this diagram, we have the two way A to D and A to BC. So based on the AND condition, A to D, what we have done 1 plus 10 that we get in the 11, and A to BC 1 plus 6 plus 1 plus 6 plus 12, so we are getting 12. So as we know, the cost of more of the ABC is, so let's take the this two. So now we have the path from G and H. So let's calculate the cost F G B G. So that would be the 5 plus 1, that would be 6, and B H would be the 7 plus 1, that would be 8. Is it true? Now I'm exploring this path.
Yes, sir.
Okay, just let me explore the other path. Now, just let me change the different color. First, I'm moving to the A to B and in this path. Okay, so B to G, that would be the 1 plus 5, that would be 6. I've already calculated over here. This one. B to G would be the 5 plus 1, that would be 6, and B to H would be the 7 plus 1, that would be 8. Am I right? So 1 plus 7 would be the 8. 1 we can get, and 7 we can get. Here we can get the 1 and we can get the 5. So which path I will take over here? G to B to G. That would be lesser than the B to G H. Is it true or not?
Yes, sir.
Okay. So the cost from BH is more than the BG, so we will take the path BG. The heuristics value from G to I is 1. So let's calculate the cost from G to I. So I've already done this path. So from G to I, what would be the my function cost? That is the 1 plus 1, that would be 2, which is lesser than the heuristics value of the 5. So now new value will be the G to I will be 2. Am I right or not? This part we have already seen and we have done.
Yes, sir. It's clear, sir.
It's clear. Am I right or not? Just tell me right now. We have
Yes,
in
yes.
the G to G, we have the 5. So I'm quitting the cost, that is the 6. Okay. And G to I am moving, so I'm spending the two more costs. The total cost from the G to I would be the my 8, so 7. So a better idea that we can replace the previous value of the heuristics value. And what is the heuristic values? Heuristic values means the search value or discover value. The heuristic word is coming from the heuristic, that means to discover something. So what I'm doing, I'm just trying to update these values to minimize the my path cost. That is only reason. So after seeing this, or after seeing this scenario, I'm trying to minimize the my heuristics value to cover the my path. So what I'm doing, I'm just trying to replace the previous value with older value. That is that can increase or may increase the my path or function cost. So if it is new value, the most the cost of the G2B must also have to be changed. So we have already changed. So if talking about the B2G, so B2G would be the 1 plus 2, that would be 3. So that is the mean of the new heuristic value, that is the B is 3. Yes, this is the point. This is our steps. Is it true? We have done already. So I'm speaking the what we have done. So B2G would be the 1 plus 2 will be 3. So that would be the mean of the new heuristic value. Is it true? We have already updated this one. 3. Just highlighting this point. Yes, see in the my highlighter. That would be 3. So we have done. Now, so what A associated with the both B and C? This path we also see. So as we can see the diagram, C only have the one choice. So one or one node to explore, that is the I. So the heuristic value of the C is 12. It is already given. So cost of C2J would be the 1 plus 1, that would be 2. So which is lesser than the heuristics value. So what we can do, we can replace such value by the 12 to 2. Is it true? We have already done. Is it visible to all? Is it clear what we have done? I'm speaking the what we have done so far. Yes, tell me. So I'm highlighting this value.
Yes, sir. Yes, sir.
So
Clear,
12
sir.
to 2, I'm 12 to 2 I'm updating. Now now so in this case, so now the new cost of a to bc would be the 1 plus 1 plus 2 plus 3, that would be 7, and which is the lesser than the a to d, that is the 11. Just tell me right now, this is the most important point. See, oops, yeah, this one, this one. See, a to d we have chosen, that was the 11. So a to bc, after I can write over, after updating hx values. Okay, so what would be the my path? Just tell me what would be the my values. I can write over here. I can write over here. A to bc, what would be the 1 plus 3 plus 1 plus 2? Can I write like this one? That would be 7. Am I right or not? So which is lesser, 7 or 11? Just tell me right now, which is lesser?
7, sir.
7. So 7 value is coming from after updating the meta heuristic. Heuristic value is not meta heuristic. Meta heuristic is different. So this is a heuristic value we have updated. So what you are observing, so we can choose the path A to BC, which is more cost effective and good than one the A to D. But this approach we have not seen in the A star algorithm. That was my point. So this was my point. In the A star algorithm, we have not seen the other paths, but what we have done in the A star, what is the minimum cost we are finding? So we are moving on to that part, and then we are observing that part. Okay, okay. But in the EOS algorithm, we have the ORing concept. By the help of the ORing or ending concept properly, we can choose the appropriate path by updating the heuristic. So if anyone asks the question where we can update the heuristic value, so there is only one value, there is one graph, problem graph we have, that is a EOS graph, where we can update the heuristic value to check whether it contains the minimum path or not. Because we have to see the other path as well. But in A star, we will not see that part. That is the biggest difference we have seen. So, but this will only happen only the algorithm explore the other path as well. If you're looking the other path explore. So in the exam time, what I will do, I can give you the any problem, a random problem, and you will explain which path is best. So first, what you will do, you will apply the A star algorithm by default. Okay. After applying the A star algorithm, you will tell me this path is better. But my question may extend. What would be the possible other exploring paths, or explain the other exploring path? So what you will do, you will you just explore the other path by applying the updating heuristics function and tell me which path would be cost effective. So it will seems to us we can do this activity within the 5 minutes now. It will take some times to write the answer properly. So for this kind of question, I can give you in the tutorial for your practice purpose. So you will do the practice and then you will learn everything properly. So in the exam time, you will not worry about that how you can solve this problem. Now come to the point. So, but according to the our this algorithm, that is A star algorithm, we will not accelerate this path here. We have just did see how the other path can also be correct. Here, what I my objective, we have seen how the other paths may correct. So A to B C we are choosing because of the updating heuristic function, but A to D will be our best one path from our previous conditions based on the A star algorithm basically. So it is not the case of the all the cases. It can be happen. It can be happened in some cases. The algorithm will get the optimal solution. So I can ask this question: what would be the optimal path? So at a time you need to explore the other path. So you have to show everything properly. Why you're choosing the other path? Because to determining the optimal path. So optimal path can be determined while choosing the exploring path. This exploring path means you're looking at the other paths as well. Else you can solve this problem within the 2 minutes, then that is not a justifiable. So your justification or answer could be just doing the or exploring the other path. That is my objective. Now it is clear to all right now. The concept is clear.
Sir,
Yes, tell me.
in the condition when we go A to D and then D to E2 or F, so we are getting the same path solution.
Where?
E to and E and F. From D to E and F.
See, what you're observing, just let me just write the thing properly. Yes, complete. See, what you're observing in the problem, just look at this problem. In the our problem here, the end arc is given. Here,
Yes.
end arc is given. So this is the reason we are just E2F we are merging. We are getting the E2F. But here other part, look at the B2GH, and here we don't have the end graph. Suppose we have, so we have to move from G to H. So we have to find the its all the values properly. But here it was clearly mentioned you are using the end graph or arc, we can say, and arc. That is then if I'm moving from F to E, so to update the to get the new value of the D, so that is reason I have to use the 4 plus 1 plus 1 plus 4. That is the only reason. So if I'm getting the 8 10 as it is, no issue. Suppose I'm getting the 9 instead of the 10, so I will update the D value, D heuristics value, that is 10 to 9 or maybe lesser than whatever the value you're getting. This is the only reason. But if it is not given into the question, so what I will do, what I can do, I can explain over here. If I can write, if this and arc not given, not given, suppose, okay, not given, not given. So what you will do, and this 4 is rather than the 2 is given. So F to D, what we are getting, just F to D in the reverse, what we are getting, 2 plus 1, 2 plus 1, that is the 3. And E to D, what we are getting, E to D, we are getting 4 plus 1, so 4 plus 1, that is the 5. So 3 is lesser than the 5. So our new, or we can say new heuristic value of the D will be 3 rather than rather than 10, rather than 10. That is updated. So this is the only
Okay,
reason.
sir.
But here what we are getting, here we are getting the ORing. So while doing the ORing, so we have to do everything properly. So what we have done, we have done due to ORing, we are adding all the values. So 1 plus 4 plus 1 plus 4. That is the reason we are getting 10. That is the reason why I
Sir,
asked. Yes, just tell me.
sir, suppose if and arc is not given
Yes.
and you have not changed the value of 4 to 2.
So, or and
So,
you are getting, yeah, you are getting the both value you are telling. Here you are telling the both values same as it is 5 5. Am I right?
yeah.
You are yeah. No issue. So that will be, we can say this would be 5 as it is, because 5 are the lesser value than the 10 which is the previous value. So we will choose the 5 as it is. No issue.
Okay, sir.
If I give you this kind of a question in the tutorial, so have you solved? Have you able to solve in the A star Gotham base and A star Gotham base? You have to update something.
Yes, sir.
Yeah, good. Okay, uh, so this is the example I have given the idea of the thing. The rest of the part you can read out from the notes. This is the everything. Just what I have explained, everything is mentioned over here. It's basically 10 is the cost of bridging the F to E from the D. So everything I have spoken already. So this is the points I have already discussed. Okay. So any doubt over here? Just right now in the ASTR algorithm you have. So we can discuss. Else we can move to the next topic. Very small topic. Just tell me right now. You have any problem?
No, sir.
Okay. So this is just idea about the ASTR algorithm we have already discussed.